In this question it is given that 0.1 meter cube of water at 80 degrees Celsius is mixed with 0.3 meter cube of water at 60 degrees Celsius. Final temperature of mixture is. So normally we'll write in terms of mass. Now over here, instead of mass, the density is given. So we can easily find out the mass of object, because density is mass divided by volume. From that you can write mass is equal to density into volume. So you can write the mass in first situation is density of water. We know that it is 1000. So we can write this as 1000 into volume is given as 0.1. So we'll get its mass is equal to nothing but we can take it as 100 kilogram. Like that, in the second situation, we can write mass M2 is equal to 1000 into 0.3. So we'll get its mass is equal to 300 kilogram. So we are mixing two liquids or water at a temperature of 80 and 60, and we can write the mass of this one is nothing but first one is 100 kilogram at 80 degrees Celsius, and in the second situation we can write that is 300 kilogram of water at 60 degree Celsius. And our aim is to find out what about the final equilibrium temperature of this mixture. Let's say equilibrium temperature is equal to nothing but T. So we can use that equation. This object is going to lose its heat energy. So there will be a transfer of heat energy from high temperature region to low temperature region. So I'll write this heat energy lost, Q lost by this object, is equal to heat energy gain by the cold object. So on both the side we can write ms delta T of heat loss is equal to nothing but ms delta T of heat gain. So you can write on the left hand side mass is equal to 100. Specific capacity of water we can take it as nothing but 4200 joules per kilogram per Kelvin, and delta T we can take it as its final temperature is going to be less than 80. So we can write difference in temperature is 80 minus T is equal to, on the right hand side you can write mass is 300 and specific capacity is 4200, and delta T is nothing but T minus 60. Now we can cancel this thing on right hand side and left hand side, 4200 and 4200. Same specific capacity is there, and there's 100 over here and 100 over here. So we can write this as 80 minus T is equal to, we can write as 3T minus 180. So if you are taking this minus 180 on the left hand side, we'll get as something but 260 is equal to this T. If you are writing on the right hand side, it becomes equal to 4T. So we can write the value of T is equal to nothing but 260 divided by 4, which is equal to 65 degrees Celsius. So we can say that the final temperature is going to be 65 degrees Celsius.